Assalamualaikum warahmatullahi wabarakatuh. My name is Salsabila Reno. I'm a student from the Geological Engineering Department in Universitas Trisakti. Today I'm going to present to you about the Oligocene-Miocene chronostratigraphy deduced from Calcareous Nannofossil in Tuban area, Northeast Java Basin. The contents of this presentation include the introduction, research methodology, result and discussion, and conclusion. For the introduction, Calcareous Nannofossil Biostratigraphy from 125 rock samples of wells SR1 and SR2 in the Tuban area, East Java, were analyzed to reconstruct the chronostratigraphy of the Northeast Java Basin. Biostratigraphic data is important for oil and gas exploration activities. Sato et al. 2016 discussed that nanofossil analysis produce a more detailed biostratigraphy compared to using planktonic foraminifera data. This research aims to determine the age of the SR1 and SR2 wells, the unconformity, and determine the chronostratigraphic framework of the depositional history of the study area. The two wells are located in the Rembang zone and are part of the Ngimbang Formation and Kujung Formation, such as this picture. In this research, terms such as first occurrence or FO are used, which is the lower age limit or initial appearance of a species. Meanwhile, last occurrence or LO is the upper age limit or final appearance of a species. Some of the nanofossil index that I found in this research are Sphenolothus chipurensis, Sphenolothus distentus, Requitor habdus carinatus, and Sphenolothus belemnos. For the research methodology, the samples for this study were prepared using the smear slice method, and a polarized microscope was used for the determination of the calcareous nanofossils assemblages, especially the distribution of the index species. This research uses primary data in the form of cutting samples with secondary data in the form of a summary log. The SR1 well has a depth of 40 meters to 1,062 meters, and the SR2 well has a depth of 35 meters to 1,486 meters, where the two wells have an interval of 20 meters. SR1 has 52 samples and SR2 has 73 samples. For the smear slide method, the steps are that first, we prepare the tools and materials to be used and then select the sample to be analyzed, then grind the sample using aluminum and a geological hammer. Then we sprinkle the ground sample on the cover glass and then add a few drops of water and spread evenly using a clean toothpick. Then afterwards, after the sample is evenly distributed on the cover glass, dry it on a hot plate at a temperature of 65 degrees Celsius, and once dry, flatten it again using a clean toothpick and separate the coarse grains. Then add Canada balsam to the preparation glass, then cover with a dry cover glass and make sure the Canada balsam is spread evenly and there are no air bubbles. Then label the preparation slide and put it in a ultraviolet box to dry the Canada balsam for 15 minutes. After that, the sample is ready to put in a sample box and ready to be analyzed using a polarized microscope. This study starts by doing the literature study for the preliminary study. Then for the data acquisition, we look at the contact sample. And for the laboratory work, there is lithology analysis, nanofossil preparation, and nanofossil observation. For the analysis, it includes lithologic columns, biostratigraphy analysis, finding the sedimentation rate and unconformity, then making the correlation. And then for the result, it's the Oligocene-Miocene chronostratigraphy deduced from Calcareous Nannofossil in Tuban area, Northeast Java Basin. For the result and discussion, there is lithostratigraphy, nanofossil distribution, sedimentation rate, correlation, and chronostratigraphy. For the SR1 well, there are 5 different lithology found, which are sandstone, claystone, limestone, coal, and slate. And for the SR2 well, lithology found are that there is sandstone, shale, limestone, siltstone, claystone, and coal. For the SR1 nanofossil distribution, there are a total of 3,292 specimens, 11 genera, and 28 species of nanofossils were found. It is dominated by the species Cyclicargolitus floridanus and Sphenolitus moriformis. It has an age from older than NP23 to NP24, which is Middle Oligocene. The fossil index found in this well are Sphenolitis distentus and Sphenolitis chyprensis. For the SR2 nanofossil distribution, a total of 2,269 specimens were found, 11 genera, 28 species of nanofossils were found. It is dominated by the species Cyclicargolitus floridanus and Sphenolitus moriformis. It has a age range from older than NP23 to N4, which is from Oligocene to early Miocene. The fossil index found in this well are Sphenolitis distentus, Sphenolitis chyprensis, Triquetrahapdulus carinatus, and Sphenolitis belemnos. For the sedimentation rate, in SR1, there is only one sedimentation rate found, which is at NP23, and it has a sedimentation rate of 100 centimeters per kilo-year. For SR2, there are four sedimentation rates found, whereas NP23 has a sedimentation rate of 52.63 centimeter per kilo-year. At NP4 has a sedimentation rate of 6.47 centimeter per kilo-year. At NP25, it is 32.40 centimeters per kilo-year, and at age NN3, it's 10.52 centimeters per kilo-year. There is an unconformity found at the age of NN1 to NN2, which is early Miocene. Next, we have the structural correlation. In this correlation, the direction of orientation is from west to east, and this correlation is done by flattening the two wells in the same depth. For this structural correlation, I connected two nanofossil datum, which are FO Sphenolitis distentus and FO Sphenolitis chyprensis, which are number 6 and number 7. I carried out a lithological correlation, and from seeing the appearance, there is a high in the western part, while in the eastern part there is a low. I interpreted this as an anticline system. Next, we have the stratigraphic correlation. I did this correlation by flattening the FO Sphenolitis chyprensis datum. This correlation is to see the reconstruction of the depositional process that occurs from the older period. And from the results of this reconstruction by flattening on datum number 6, it shows a pattern of deepening in the west where the sediment thickness is more thinner than SR2. And by looking at the changes in lithology, which are shown in terms of lithological type or the grain size, as it gets younger, there is a pattern of fining upwards, which is indicated by a transgressional process. And as you can see, on the age older than NP23, there is hole present, where I interpreted this as a terrestrial environment. Next, we have the chronostratigraphy. It starts from NP23 to NP24, where lithology such as limestone, clay, coal, shale, silt, and sandstone are deposited. In this age, the global sea level change is increasing, and it has a cold climate with a temperature of around 2 degrees Celsius. And at this age, the tectonic evolution is that there is a subsidence in the basin. Next is NP25, where lithologies such as limestone, shale, and silt are deposited. In this age, global sea level change is increasing due to the late Oligocene warming that occurs, and afterwards, towards the end of Oligocene, there is Miocene glaciation. Because of the glaciation, the global sea level change decreases. At this age, a local tectonic event occurs, such as an uplift in the foreland basin. Then we have an unconformity at age NN1 to NN2, which is early Miocene. This is due to the convergence of the Indian plate resulted in an compressional tectonic regime in Sumatra and Java in the forearc region causing basin inversion. Next is NN3 to NN4, where lithologies such as limestone, sandstone, and shale are deposited. Around this age, global temperatures are around 4 degrees Celsius. At NN3, sea level change are relatively decreasing, and at NN4, sea level changes are increasing. And finally, we have come to the conclusion. There are 3 points. The first one is based on biostratigraphic analysis, the age of the lithological unit in SR1 is MP23 to MP24, which is early to late Oligocene. And for SR2 is MP23 to NN4, which is early Oligocene to early Miocene. Number two, the unconformity is only detected in SR2 well, which is characterized by the missing ages of NN1 and NN2. And finally, the interpretation of the chronostratigraphic chart confirms that the oldest known deposition process in the area starts from NP23 to NP25, in which the transgressive period due to the global sea level change rises during the late Oligocene warmth event. After that, an unconformity occurred at NN1 and NN2 caused by the Miocene glaciation in the transition of the Oligo-Miocene epoch. The deposition resumed at NN3 to NN4 of the early Miocene during the transgressive period during the mid-Miocene climatic optimum. Thank you for watching my presentation. Wassalamualaikum warahmatullahi wabarakatuh.